I'd like Raf Meersman from Comsof to come up, and he's going to tell us all about this exciting way forward. Please welcome Raf.
Hello, everybody. I'm very pleased, and I would like to thank the organization as well to give the opportunity to speak to you today about this very hot topic on the relation between 5G and fiber. In fact, in the panel just before, we noticed there's already a lot of things having been said about why 5G and fiber are things that correlate. And if you look at the program of a fiber conference like this one over the past 2 years, for sure always you find a lot of topics and presentations on 5G. So I'll try in this presentation to take first slightly a step back, and for those, we hear it in the panel, 5G needs fiber, but I first want to take a small step back and dive a bit deeper into that reasoning, because I still hear people coming to us and talking about, yes, but why not using microwave or copper technology as a backhaul technology for 5G? So I just want to give some more flesh to the bone why we believe fiber is really unavoidable. But more importantly, I also want to give you a bit of insight on a project that we are doing within the FTTH Council Global Alliance, and for which I've been asked to be the project manager, and where we also want to try and really quantify the benefits of convergence between fiber for 5G and fiber for other applications. So maybe just a brief background from myself. I'm the CEO of Comsof. We are a software company who are creating software to design the fiber networks in an efficient and highly automated way. And from that experience, from more than 10 years, we've been, for example, also involved in cost models for the fiber to the home council on the cost to deploy fiber across the whole of Europe, for example. There's some interesting reports of that you can find on the Fiber to the Home Council Europe website. And so from that experience, I was actually asked now to do a similar project on the costing of the fiber in relation to 5G. So it's a bit in that context and in that role of project manager that I'm happy to take you through these slides. So as you all know, 5G is something different than 4G, and well, this is a nice illustration that 5G obviously outperforms 4G on all levels. It's more bandwidth, it's lower latency, more devices can be connected, more efficiency from an energy perspective. So it's much better technology, but all magic comes with a price. So there is obviously also a bad thing, not a bad thing, but a challenge related to those improvements. And that challenge also obviously relates, first of all, to the fact that we'll be using more spectrum for these higher bandwidths. These higher spectrum, higher wavelengths and things will have a very important impact on the propagation of the wireless signal. So we are also working together as Comsof with a company called Cyrodiil, who are specialized in a propagation model for wireless signal. And you see an illustration on this slide where on the top, for a lower frequency, how a signal from a central point propagates through a street, considering also the buildings and all the obstacles in that street. And then you see a similar simulation on the bottom for a higher frequency, 50 gigahertz, and it's clear from a physical point of view that obviously the range you can get with those higher frequencies is much smaller. So that's the trend to densification that is clearly driven from the enlargement of a spectrum, but bringing down the range that you can get from your side. And actually, if you look at that from a broader perspective, I think this was a very interesting figure and study that was done a couple of years ago, where they looked back at the increase in speed that was realized on the wireless spectrum over the last 60 years, which is enormous. But if you look at the real reasons and the real cause of those increases in speed, then in fact, ultimately you're always paying a price of reduced range, reduced cell sizes to really get that speed higher. And that's why we believe, well, densification is unavoidable in these scenarios. But there's a second aspect, and the second aspect is also in 5G, that we will be looking at backhaul or fronthaul with a whole different perspective. And it's partly driven by that densification. So what's happening is that due to the fact that you're introducing much more sites across a certain area, it becomes unaffordable to put too much intelligence in every site. So the trend is that the intelligence, a baseband unit, is moving higher up in the network. It's not present at every site. And that also means that all the traffic from a site cannot be processed and optimized anymore for further transport in the network, but you have to carry those signals in a more raw state through your backhaul or fronthaul, in this case, connection. And then you see these figures on this slide on what that means in terms of also the capacity that you need from the site to the higher up in the network, to the nodes higher up in the network. And the latency as well, because the synchronization between the sites are happening at a more central point. And of course, if you then look at 5, 7 gigabits per second speeds per site, there is clearly no technology that will be able to do that except for fiber technology, or at least also considering the economics of it, it's clear that fiber is the only technology for doing that. So, as an introduction, that means we see 5G, the need for a densification of the sites, and at the meantime, a higher speed and lower latency for all of these sites, where fiber is the only technology that can really deliver that. So that's a unique combination, and that's really the reason why indeed so many talks are about 5G when we are at a fiber conference. But now we want to quantify that a little bit more. So therefore we are looking at real life examples. And in this case, for example, you see a certain area in a street map. And this is a simulation of what a 5G network could look like in order to reach a 90% coverage outdoor for 5G equipment and connections. So the model will actually look at the ideal places of a cell site, and then you see how that signal is distributed across the whole area. And if you look at that from a bit higher level, it's clear that actually a site is almost virtually at every corner of a street, or almost in any street, if you really want to get to a good coverage. Now, like we said, okay, densification, it means these cells are really, like here, distributed across an area, 8 to 10 times, but maybe in the future even more. And then we talked about a fiber connection. So this is an illustration of how a fiber network connecting all these sites to a first level central baseband unit, and then through a second stage in a backhaul, bring that data further to a central office of an operator, how that could look like. And well, so the colored lines represent now a fiber connection. And the interesting thing is, if you look at this and the combination of these two layers of fiber network, it's you have fiber in every street, because you need to go from site to site, and they are distributed in a very dense way across the area. And that means there is indeed first time that there is such a need for a massive wired network to enable the wireless technology. And like I said, in the project that we launched now with the Fiber to the Home Global Alliance, we are trying to look at the costs of fiber deployment for 5G and fiber to the home, and more precisely also on the potential savings from considering both technologies while deploying the fiber. And when we talk about cost for fiber deployments, of course there's a big difference, but in a lot of countries fiber goes underground, and then trenching and civil costs are a major part of the whole deployment cost. Of course, there are ways, and because it's so big and so important in terms of cost, there are ways to look for alternatives to bring down the cost. Aerial overhead deployments, for example, is obviously gonna reduce the total cost, avoiding the whole construction of the trench, but has some other constraints around lifetime, especially if you are in a place where there can be some more natural disasters happening over time, or capacity that can go on poles. In some areas you have a very large infrastructure of existing ducts that you could reuse for a large extent, avoiding trenching in some parts. And then you have new technologies like mini and micro trenching, which can bring down the cost significantly. But there's also something simple like synergy or convergence between applications that are requiring a trench. And this can be on a very high level with electricity networks being deployed. So all kinds of utility networks going underground. Of course, it's the first synergy option to see if there's anything happening on one network, why not reuse that for a deployment, for example, of fiber. But there's also this synergy and this convergence by thinking ahead when you deploy a fiber for 5G, that for the future you might just want to reuse that trench in a longer strategy to extend further to fiber to the home, because not for every area, but for a lot of areas, I don't believe 5G is the true alternative for fiber to the home. I strongly believe it's more an enabler for getting already close with your fiber, but ultimately it will then also bring down the step for that last part, and with the fiber to the home again, the ability that you can offer as an operator will go up significantly. I still compare it also to my home. Okay, Wi-Fi is great, but there's still a lot of devices that I'm connecting to a wired connection because I need more bandwidth or I need a higher availability of it. So I think it's still a combination of the two that will be the case. And so what we are trying to do is to look, if you're building fiber for 5G, or maybe if you have plans for fiber to the home, how can you consider both worlds and try to build the most efficient infrastructure and benefit from the convergence between those two infrastructures? So let's look at an example to illustrate again what we're trying to quantify. And again, there's a lot of things going around in the industry on these 5G and fiber networks. But we believe, or what we are lacking a bit, is some real numbers. And that's what we're trying to add with this study. So just as an example, we're looking here at the medium dense area. 22,000 inhabitants divided over a number of single dwelling and multi-dwelling units. So it's a residential area mainly. And when we do a simulation on the 5G coverage for 95%, we end up with 634 cells that are needed to get a good coverage in this complete zone. And with those sites, we can then start calculating the fiber front haul and backhaul network, which is in this case a fully underground network. That's an assumption. And we also foresee 2 fibers per site, which also means we're typically looking at WDM active equipment to increase the speeds on those fibers. You could also do simulations with more fibers. Those are things we also want to take along in the study. And like we said before, if you would zoom into this output of the design, you would actually see that virtually in every street, at least on one side of the street, we are making a trench and putting down a fiber cable. Now for the same area, we are creating a design for these 22,000 inhabitants across approximately 10,000 living units. We are creating now a design for an efficient fiber to the home network. Again, an underground network, in this case 1 fiber per home on a GPON network. And we are looking at the whole design and quantifying the cost and the trenches that are needed to build this network. And because it's a relatively dense area, if you would zoom in on a street level, you would actually see that most of the streets, in this case, we're actually trenching along 2 sides because there are houses on 2 sides of the street. But one side was already used for the 5G, so you see it's easy to see the potential of the convergence. And if you put that into a graph, then you see the cost of a fiber to the home network, and this is just an illustration. It's not yet a final result, so we are working towards more specific results, but just to illustrate what we are going to have as results soon, is that you will have a cost for a standalone fiber to the home network in a certain area. And you have a cost for a 5G fiber network in the same area. And of course, if you build them separately as 2 operators, or even as 1 operator, but over time, you didn't foresee capacity in the first network that you built, then you end up with an overbuilt technology, an overbuilt network, and you put the costs on top of each other. And what we want to look at is, if you consider both, what is then this saving and this potential value of convergence, and how much can we bring down the total costs by intelligently considering those opportunities. And this is where it becomes interesting for the business case as well, because we've been hearing in the panel that they're saying, yeah, there can be a business case for 5G, but maybe not for fiber to the home or things like that. So with some numbers on these cases, what we want to look at is, if you have the converged cost, you could allocate those costs, because there's a lot of costs shared. You could divide them between the services, and that's where you can have a reduction, a significant reduction in the cost for example, for the fiber to the home business case, benefiting from the fiber to the antenna. But also the fiber to the antenna is cheaper in itself. So we have a positive impact on both business cases by looking further. But it's even getting more interesting, and that's why I was saying, if you have, for example, a fiber to the home business case that works, actually if you consider the convergence, the incremental cost to add the fiber to the antenna will be really, really small. Or the other way around, if you have that business case for your fiber to the antenna for 5G, actually if you allocate that to a business case for 5G, the step to extend that to the fiber to the home is really getting very small. Well, very small. It's still significant, because going into the houses is a significant cost. And we want to now quantify some of those benefits, because this could be on the longer term then a real trigger to bring also such areas into a fiber to the home deployment in combination with a 5G, which will always be more for the mobility part then, and can be complementary to fiber to the home. So just a few more words about the project itself, the Global Alliance project. Our objective is, like I said, to really put up some numbers and demonstrate the value of convergence between those 2 networks. And we want to do that by considering a series of scenarios on different type of areas with different assumptions, because every area is different, every case is different. So what we don't want to do is to come up with one number, because that simply doesn't exist. On the contrary, we want to get some insights and give people, for example, also regulatory people, really a view on the importance of those opportunities and why it's important to take them along. And so we are working towards some first results. We are actually targeting the end of the year for a full report. And in that report, we also want to be very transparent on our assumptions. What have we taken as an assumption for example, a cost for trenching, about the density of the network we are applying, what was our assumption on the small cell range. And we want to do that because our results are not intended, like I said, as being the truth, but as a way of starting to think about it, and then, of course, also open for discussion. If you don't agree with the assumptions, we can obviously look at adjusting the assumptions. But, like I said, we are looking at different assumptions and aspects that we want to combine into, let's say, a dozen of scenarios to be worked out, and that will give us a real view on how this convergence value differs between the different cases. Just to highlight some of the dimensions that we're looking at, first of all, the density of the area. Talking about a very dense city center will be a completely different case than a medium dense residential area, or a lower density area more towards rural. So there will be a completely different dynamics between the costs. We will also look at different cell ranges, cell sizes, that will have an impact clearly on the convergence value. We will look at different business models from the fiber, like the dark fiber ones, who are probably interested when they deploy fiber in getting enough fiber there so that a lot of operators can use it, versus a vertically integrated operator who would just deploy for his own business and probably do it as efficient as possible with as little investment as needed for his own case. There's a big impact of underground versus overhead deployment, so that will be an important assumption that we'll take some scenarios on. And then there's the last part which we want to look at, that is, if you look at it from a direct deployment for a one-time converged network, or more realistically probably if you take a different time view, that you first deploy one, but considering the future, you already foresee all the components and capacity for the extension later on, and what that does with your overall costs. So last word on the timing. Unfortunately, it's a little bit too early to bring up the real figures, but we are in the process. So we started the work in June. We are gathering the last inputs as we speak, because our target is from October to have a clear description of the scenarios and the cases that we're going to calculate. And then during October, we will be executing the cost modeling and the calculations on all these scenarios. We will consolidate the results, and then starting November until the end of the year, we will work on the reporting of those figures. So for sure in the next conferences and online via the councils, you will be able to follow and look at those results in the near future. So wrapping up or concluding what we are trying to do. So there is a consensus that 5G drives densification and needs fiber. So that means there is a significant overlap with fiber to the home deployments, and thus a big value in convergence between the networks, or you can turn it around, a big cost if you don't use the convergence. And that's what we target to evaluate in our study, not just as one figure, but as a range of results across different cases and scenarios. Just want to say, okay, if there's any questions, I'm happy to take some, but I guess if anybody's also interested and has some insights from his own, I would very much welcome you, because we're still in the validation and input gathering stage, to come up during breaks and come talk to us, because we're still interested in getting as much input to our study and assumptions as well, and make sure they're validated across the industry. So we are very much welcoming everybody's input. So that was it. Thank you. Any questions?
Are there any comments, questions to Raf? There's a question there. Let me grab a mic.
Thank you. Again, Johan Kruger from Eurotel. The basic in the past was the towers and now the densification of the towers. What is the possibility where you can actually, if you do FTTH, where you can put like a pico that every guy in his router, that there could be a 5G radio card at each house? I mean, that's a whole different model, but it will bring down the cost of the towers. There's already going fiber to the homes. Is that probably part of the pico cell? I'm not sure if that's pico even.
Yeah.
Is that, if you can maybe just comment on that?
Well, for the moment we are mainly, I think you can look at things from indeed two applications. You can look at 5G as a way to bring, to focus on the mobility outdoor. This is our main focus at the moment, but you can also look indeed at 5G as a way to really bring the last part of the internet into every home. But then you're indeed, like you refer to, then you're practically bringing an extra fiber for a 5G or fiber to every building or home in order to enable that. So then of course the similarity or the convergence and the difference between the two networks becomes very small, and the value of convergence becomes higher. But our study for the moment would focus more on the 5G as a mobility outdoor solution, as that is, let's say, more compatible with a fiber to the home scenario. Does that answer your question?
Any other questions or comments? No? Will the report also be available on the Comsof website or just through the councils?
I think it's normally it's going to be published on the websites of the councils, yes.
Okay.
I'm pretty sure.
That's where we'll look for it. Thank you very much. Big round of applause again, please.
Thank you.